2007 Canadian Open Mathematics Challenge, Part B. An arithmetic sequence a plus d, a plus 2d, is a sequence in which successive terms have a common difference d. For example, 258 is an arithmetic sequence with common difference d equals 3, because 5 minus 2 is equal to 8 minus 5, which is 3. Part A. If x minus 1, 2x plus 2, and 7x plus 1 are the first three terms of an arithmetic sequence, determine the value of x. So they give you a little clue there, actually. I don't know if people pick up on that, but regardless, I'll just show you. An arithmetic sequence is going to be like this, right? A plus d, a plus 2d, and so on. So they've given us that in this case, it's x minus 1, 2x plus 2, and 7x plus 1. So if you take this one and subtract from it that one, a plus d minus a, what do you get? Well, you just get a, right? Similarly, you get d. You get d. Okay, so similarly, if you take that one and subtract from it this one, a plus 2d minus a plus d, you will also get d. So you're basically going to do the exact same thing, but now with these guys. So you would take 2x plus 2 and subtract from it x minus 1. And then over here, you would take this guy, which is 7x plus 1, and subtract from it this one, which is 2x plus 2. And both of these will be equal because they all both equal d. There you go. That's the mathematical equation. So let's solve this. So 2x minus x is x. 2 minus 1 is 3. On this side, 7x minus 2x is 5x. 1 minus 2 is negative 1. So this means 4x is 4. X is therefore equal to 1. So that takes care of part A. Part B. For the value of x from A, what is the middle term of the arithmetic sequence x minus 1, 2x plus 2, 7x plus 1, all the way up till 72? All right. So it's just a continuation. So they've got x minus 1, 2x plus 2, 7x plus 1, ... all the way till 72. Okay, and they want me to use this value. Okay, so when x is 1, this looks like 0. This is 4. This is 8. And that means that the d in our case is 4. It's going up by 4. All right, so I've got to get all the way to 72. Sure, no problem. 0, 4, 8, 12, 16. There's not that many, so I'll just write them all out. I don't mind. 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72. Right, because it goes all the way to 72. They want me to find the middle term. So first of all, how many are there? There's 5, 10, 15, 19 terms. The middle term will be the 10th term, right? So it'll be this one right here, because there's 9 before it and 9 after. Okay, so the middle term is 36. And keeping it going, a geometric sequence, AR squared, ... is a sequence in which successive terms have a common ratio r. For example, the sequence 2, 10, 50 is a geometric sequence with common ratio r equals 5, because 10 divided by 2 is equal to 50 divided by 10 is equal to 5. If y minus 1, 2y plus 2, 7y plus 1 are the first three terms of a geometric sequence, determine all possible values of y. So again, they've kind of given you a little bit of a hint here, which I hope you pick up on. They're kind of telling you what to do, which is nice of them. So, as before, let me explain. We've got AR squared as the first three terms of a geometric sequence. In our case, it's y minus 1, 2y plus 2, and 7y plus 1. Now, if you take the second term and divide it by the first term, you get r. If you take the third term and divide it by the second term, you get r. So that is what we're going to do. In our case, our second term is 2y plus 2 divided by the first term, which is y minus 1. And we're going to do that again, just like here. We take the third term, which is 7y plus 1, and divide it by the second term, 2y plus 2. And both of those is equal to r, so that means these are equal. And there you go. You cross multiply and off you go. So here we go, cross multiplying. Let's see here, 2y plus 2 times 2y plus 2. On the other side, y minus 1 times 7y plus 1. And if you cross multiply, you get 4y squared plus 8y plus 4, 7y squared plus y minus 7y minus 1. And then I guess we'll put everything on one side. So 3y squared, let's see here, 6 minus 8 minus 14y, and then minus 5, right? So does this factor? I hope so. 3y, y, 1 and 5, I think. Positive, negative. Yeah, that should do it. Okay, that's great. So that means y is either 5 or negative 1/3. Now, did they say anything about positive or negative here? No, just all possible values. Okay, and there's nothing about them being integers either. Okay, so I guess that's it. These are the two values of y. So they said all values, so those are the values. Okay, moving on to part D, which I'm assuming is a continuation of part C. For each of the values of y from C, there you go, determine the sixth term of the geometric sequence y minus 1, 2y plus 2, 7y plus 1. All right. So first we'll do it for y equals 5, and then we will do the same thing for y equals negative 1/3. It's negative 1/3, yeah. Okay, so with y equals 5, these ones, y minus 1 would be 4, 2y plus 2 is going to be, what, 12, 7y plus 1 will be 36, and so on. So it looks like the ratio is 12 over 4, which is 3. So it's just going up a factor of 3. So you're multiplying by 3 each time, so it'd be 108 for the next term. Then the next term would be 324, and then the sixth term would be 972. Okay, let's do it for y equals negative 1/3. Again, plugging y equals negative 1/3 into that. For the first one, it would be negative 1/3 minus 1, which is minus 4 over 3. Then 2y plus 2, when y is negative 1/3, would give me negative 2/3 plus 2 is 4 over 3. And then 7y plus 1, so that'd be 7 over 3 negative plus 1, which is negative 4 over 3. Okay, so this time r is just negative 1. So I guess this just alternates back and forth. Negative 4 over 3, and then positive 4 over 3, like that. So the sixth term here, 1, 2, 3, 4, 5, 6, is positive 4 over 3. In the diagram, angle ABC is equal to angle BCD equals 90. Also, AB is 9, BC is 24, and CD is 18. The diagonals AC and BD of quadrilateral ABCD meet at E. Determine the area of the quadrilateral ABCD. Well, I think that's pretty straightforward. ABCD would basically, we can just draw a line that goes down from A to the bottom like this, perpendicular. I draw it like that. And therefore, all it would just be is the rectangle plus the triangle. The rectangle is just 9 times 24, this rectangle right here. And then the triangle, which is this one, is 1/2 base times height. The height is 24, and the base is from here to here is 9, because this is 18, and then from here to here is 9. So that's just 18 minus 9. So plus 1/2 base, which is 9, times height, which is 24. And this is 216 plus 108, and that is 324. So that takes care of part A. Okay, great. So now we go to part B. Determined the ratio DE over EB to be 2 to 1. Okay, so we have to show that. All right. Boy, oh boy. So I think we have to do this the way of the lines and then the distances. Okay, so that shouldn't be a problem. So line BD, I've got to find the equation. Now we have the coordinates, right? C is just the origin, that's 0, 0. D is 18, 0 in terms of its coordinates. B would be 0, 24. And then A would be 9 and 24. Yeah. Okay. So I think I can get the equation pretty quickly. So BD, as always, we have to get y is equal to mx plus b. M is the rise over the run. So that's going to be 24 minus 0 over 0 minus 18. And that is equal to minus 4 over 3. So then we have y is equal to minus 4 over 3x plus b. To get b sub in any of the coordinates, I'll just put in this guy. 0, 24. When I do, I get 24 is equal to 0 plus b. B is therefore 24. So the equation is y is equal to minus 4 over 3x plus 24. The equation of line BD. Line AC, which is the other one, I'll let you do that since you're an expert. That is just y is equal to 8 over 3x. All right, I'm certain you know how to figure out the equation of a line by now. Now we need to find this intersection point E. So set these two equal to each other. So that means that minus 4 over 3x plus 24 is equal to 8 over 3x. So that means 24 is equal to 12 over 3x. And therefore x is equal to 6. Sub it back into any one of these guys to get the y coordinate, and when you do, you get y is equal to 16. So E, the coordinates of E, all important, are 6 and 16. This E, this right there. Okay, so that is just only part of this question. Now we have to show the distances, and that can be done pretty easily with the distance formula. We have to show the distance EB, and then we have to show the distance DE, and then that should be able to be in the ratio 2 to 1. Okay. So EB using the distance formula would be 0 minus 6 squared plus 24 minus 16 squared, all under the square root sign. So that's 36 plus 64, and that is equal to 10. ED, or DE, same thing. Let's see here, where are we? We're using these two coordinates now. So that's going to be 6 minus 18 all squared plus 16 minus 0 all squared under the square root sign. So that is 144 plus 256. That's 400, so that's 20 if you take the square root. So now finally, my DE over EB is 20 over 10, which is 2 over 1, exactly what they wanted us to show. All right, moving right along. Now we're up to C here. Okay, I think I need some space. Okay, I think I should be able to fit it in. C, determine the area of triangle DEC. DEC. All right, so DEC, that's that. Okay, that shouldn't be a problem. That base is 18 and the height is the y coordinate of E, right? So that's 16. 16 is the height there, if this represents the height. So the area of triangle DEC is 1/2 base times height. The base is 18, and the height is 16. So that's 144. Okay, that was pretty straightforward. And then finally, this one, determine the area of triangle DAE. DAE is this green guy. Okay, so DAE, I think we're going to have to use everything. So DAE is going to be the whole shape, which was ABCD. And then we're going to subtract DEC. And then we'll subtract BEC. And then we'll subtract the small guy upstairs, BAE. And that should leave me with just DAE. ABCD, we got, I think, in the very first part, right there, 324. DEC, we just got here, 144. And then BEC is pretty straightforward. That's just 1/2 base times height. So 1/2, the base is 24, and the height is the x-coordinate of E, which is 6. Yeah. And then for the small guy, again, 1/2 base times height. The base is 9, and then the height would be the distance from 16 to 24 on the y-axis, which is a distance of 8. So there you go. And then this math is 324 minus 144 minus 72 minus 36, and that is 72 when it's all calculated. And there you go. Alphonse and Beryl are back. They are playing a 2-person game with the following rules. Initially, there is a pile of n stones, with n being greater than or equal to 2. The players alternate turns, with Alphonse going first. On his first turn, Alphonse must remove at least 1 and at most n minus 1 stones from the pile. If a player removes k stones on their turn, then the other player must remove at least 1 and at most 2k minus 1 stones on their next turn. The player who removes the last stone wins the game. Determine who should win the game when n equals 7. Explain the winning strategy. So n is 7, so that is what we're starting with. And Alphonse goes first, and then Beryl, and then Alphonse and Beryl, and so on. They are alternating turns, right? Now, we will put up here how many are remaining, and we will put how many are to be removed. Okay, so when the game first starts, there's 7 that are remaining. Nobody's removed any yet. Okay, so the strategy that Alphonse needs is that he should only remove 1 stone. If he does, then that means my k is equal to 1. And I'm referring to this very important rule up here. If a player removes k stones on their turn, then the other player must remove at least 1 and at most 2k minus 1 stones on their next turn. So that means Beryl, who starts off with 6, how many can she remove? Well, it's between 1 and 2k minus 1. When k is 1, it's going to be between 1 and 2k minus 1 is equal to 1 when k is equal to 1. So Beryl has no choice but to remove 1. She can't remove any more than 1, so she removes 1. Alphonse now has 5 to choose from. He has to keep just choosing 1. It's down to 4. Beryl chooses 1. Now you say, why doesn't Beryl choose 2? Because she can't. The k is 1. If k is 1, according to this rule, she can only remove 1. So that's what she does. Now it's down to 3. Alphonse continues with his strategy of removing only 1. Now it's down to 2. Beryl removes 1. It's down to 1. The player who removes the last stone wins the game. Alphonse removes the last stone. This is the last stone, and therefore he wins the game. Wins. A wins. So this is the strategy. And in summary, basically, is that the strategy is that Alphonse removes initially 1 stone. Once he does that, everything is going to be sort of fixed for Beryl. She'll be trapped, and she can only remove 1. And then Alphonse just continues to remove 1 because sort of he's got control now. And also Alphonse has no choice but to remove 1 anyways. So he has no real choice. He can't remove 2 or 3. So once he makes this first initial move, he's guaranteed to win, as long as n is equal to 7. I mean, this was only for n equals 7. Okay. Now we're going to determine who should win the game when n equals 8. Okay, hopefully this kind of behaves in the same way, but something tells me because it's part B, it's a little bit more challenging. All right, n equals 8. Same story. I think Alphonse is going first again. So A, B, A, B, A, B, and so on. Okay, so we got remaining. And if I can spell remaining, and removes. Okay, so it starts off with 8, so we have 8 remaining when the game first starts. Okay, so there's quite a few choices here now. Let's start off with Alphonse initially choosing 1, and let's see what happens. Right? If that's the case, based on this rule explained in the previous part, Beryl has no choice but to remove 1. So it's down to 7, removes 1. And then from now on, it's fixed. Everybody has no choice but to remove 1 because of this rule. So it becomes 6, then 1, 5, 1, then 4, 1, then 3, 1, then 2, 1, and then 1. This is the last stone, and Beryl removes it, and therefore Beryl wins. So Beryl wins when n equals 8 and A removes 1 initially. Okay, that's great. But what about if A removes 2? Okay, let's see what happens when A removes 2. So same story, A, B, C, D, whatever, or A, B, there's no C. But now we're going to see what happens if we have a initial move of 2. Now, according to that rule, Beryl, since k is equal to 2, can remove anywhere from 1 to 2k minus 1, correct? Now, 2k minus 1 when k is 2 would be 3. So Beryl can remove anywhere from 1 to 3. So she's got a choice now. She's not fixed like before. But at the same time, there's got to be some sort of strategy that she can use. Here, she had absolutely no strategy. She was completely fixed with regard to what she could do. So therefore, there's no way she could win. But here, because she has a choice now, she can probably manipulate or strategize what she does. Here, she won even though she had no choice. So that was sort of great. But here, she does have choices for her first move. First of all, if A removes 2, how many are left? Well, there's 6 remaining. Beryl now has to be very careful about what to do here. So because she wants to win, or everybody wants to win, Alphonse wants to win too. But let's see what happens. Beryl is going to choose 2. 2 is the right thing to do here. Because if she chooses 2, then there will be 4 remaining. Correct? Now Alphonse, because k is 2, also now has this choice that he can choose to remove anywhere from 1 to 3. So now we have to figure out 3 different scenarios. If he chooses 1, if he chooses 2, or if he chooses 3. If he chooses 1, then there's 3 left. And now Beryl can just be fixed. It'll be 1 because that's the only number she can remove. It's down to 2. Beryl removes 1. It's down to 1. Beryl removes that last stone and she wins. So Beryl wins. But that's just one scenario. What if we started off here, which is 2. Beryl removes 2 because that is the strategy she must use in order to win. So that's fixed. But now Alphonse, instead of removing 1, decides to remove 2. What happens then? Well, then we now have 2 left. Beryl will now remove 2. Or sorry, not 2. Yeah, she'll remove 2 because that way she will have removed the last stone. And she's allowed to remove 2 because K is 2. And therefore, she can remove anywhere from 1 to 3. Now, the last strategy or pathway is the same kind of start off. There, Alphonse chooses 2, and then Beryl chooses 2 because that's the right thing to do. But then Alphonse now chooses 3. So let's put that there. Then if he chooses 3, there's only 1 left, and then Beryl removes that last one. So in all 3 scenarios, whether Alphonse chose 1, 2, or 3, Beryl can win. So Beryl wins. So the key is, if Alphonse chose 1, Beryl wins just by sort of default. If Alphonse chooses 2, then Beryl has to choose 2, and then no matter what happens then after, Beryl wins again. Okay, so hopefully that's clear. Now what happens if Alphonse initially starts off with 3? See, initially here was 1, initially here was 2. What if he starts off with 3? Okay, let's explore that. A, B, A, B, A, B. Starts off with 8. He selects 3. There's 5 left. K is 3, so that means Beryl has a choice to choose anywhere from 1 to 2K minus 1. When K is 3, 2K minus 1 will be 5, correct? Okay, so Beryl can choose anywhere from 1 to 5. Well, choose all 5. And that way you've selected all the stones, including the last stone. Beryl wins. All right, so we did 3. What if Alphonse chooses 4? Well, let's see. Let's see what strategy Beryl can use to win. Starts off with 8. Now Alphonse chooses 4. K, therefore, is 4. That means Beryl can choose anywhere from 1 to 2K minus 1, which would be 7. Okay, there's 4 left, so Beryl can just choose 4, right? Because she's allowed to choose anywhere from 1 to 7, so just choose 4. That means she will have taken the last stone, and then she wins. And similarly, if A initially chooses 5, 6, 7, Beryl will win very easily, actually, in the same way that she won up here when Beryl chose 4. So there you go. That's the sort of the complete explanation of what happens when n equals 8. Beryl can always win if she implements this type of strategy. A cat is located at C, 60 meters directly west of a mouse located at M. The mouse is trying to escape by running at 7 meters per second in a direction 30 degrees east of north. The cat, an expert in geometry, runs at 13 meters per second in a suitable straight line path that will intercept the mouse as quickly as possible. If t is the length of time in seconds that it takes the cat to catch the mouse, determine the value of t. Okay, so I'm going to need some space here, so let's move this diagram over, and let's just use this diagram. And I'll just draw it again because I'm going to need to label it, and it's going to get all messy. Okay, so it doesn't have to be a work of art, just as long as it sort of explains the basics. So here we go. This is 60, this is C, this is M, this is 30 degrees, this angle in here, and this is a right angle the way I've drawn it. Okay, so speed is equal to distance over time. That's a very important formula. So distance is equal to speed times time. So since this speed is 13, the distance will be 13 times t. So if I'm labeling that distance, it'll be 13t. And similarly, since this speed is 7, that's the speed of the mouse, this distance from here to here will be 7t, like that. Okay, And let's see what else I can do. This is 60 degrees. And since this is 90, this would be 30 degrees. So we got a 30, 60, 90 triangle. And the ratio of the sides of a 30, 60, 90 triangle, hopefully by now you know, are 1, 2, and root 3. So that means if this is 7t, then this will be 7t divided by 2, because the ratio is 2 to 1. And similarly, this distance would be 7t over 2 times root 3. Yeah. Okay, I think we have a Pythagorean relationship in this big triangle, this right triangle. And that is that 60 plus 7t over 2 all squared plus 7t over 2 root 3 all squared is equal to 13t all squared. Correct? Okay, so I think that should be sufficient. All right, so we got to expand this whole thing. So we got 60 squared plus 420t plus 12.25t squared plus 36.75 t squared is equal to 169t squared. Put everything on one side, and you'll have 120t squared minus 420t minus 3600. And then divide through by 120, and you'll get t squared minus 3.5t minus 30. And I'm pretty sure this factors t 7.54 negative positive. So t is either 7.5 or negative 4. And since t represents a time, it's obviously not going to be negative. So t is equal to 7.5. So that is the answer to this question, which, to remind, was if t is the length of time in seconds that it takes the cat to catch the mouse, determine the value of t, and it's at 7.5 seconds. Okay, great. So we got part A. Part B. Suppose that the mouse instead chooses a different direction to try and escape. Show that no matter which direction it runs, all points of interception lie on a circle. All right, so this is going to be a little bit more challenging. Okay. All right, so we got a diagram there. I'm going to stick to the diagram this time, the one that they gave me. So what I'm going to do is I'm going to draw a little line perpendicular to the x-axis. And I think that should be all I need for now. Okay, so they told me that this is 30, but then in this part B, they're saying that we are not using 30 anymore, no matter what. So they're saying no matter which direction. So instead of 30, I've got to just use theta this time, because they don't give me an actual, they're saying whatever happens. So for any theta, basically, no matter which direction the mouse goes. Okay. This is a right angle, the way I drew it, and then therefore this angle will be 90 minus theta, since this is theta, and this is a right angle. And therefore, this is the point where the mouse and the cat meet, right? The point where the cat catches the mouse. So it obviously is going to have some coordinates x, y. And based on trigonometry, the cos of 90 minus theta, if you look at just this triangle right here, will be equal to x over the hypotenuse. And the hypotenuse is a distance, and the speed is 7. The speeds are the same in part B of this question. So remember we had that formula, speed is equal to distance over time, and therefore distance is equal to speed times time. So this hypotenuse is, speed is 7, so 7t. So 7t, like that. So that means that cos of 90 minus theta times 7t is equal to x. And the cos of 90 minus theta, if you remember trig laws, is actually the same as the sine of theta. So that's a little bit cleaner. And then don't forget that 7t, and that's equal to x. Okay, great. And in a very similar way, we can show that with the same triangle, that the sine of 90 minus theta is equal to y over 7t. Y over 7t. And therefore, 7t times the sine of 90 minus theta is equal to y. And again, using trig rules, sine of 90 minus theta is the same as cos theta. So there we go. Is equal to y. So this xy can really be written as x is 7t sine theta, and y is 7t cos theta. Okay, so that's pretty decent start to this question. Okay, so I'm gonna need some space here. So let me move this all over. Okay, all right. So now let's get some boundaries of what can happen, sort of an extreme case scenario. If this mouse decides to go directly east and then directly west. So in a very sort of quick diagram, the mouse starts off here, right? And the mouse starts off at the origin. And if he goes directly east, then he's going to go directly that way. And then the cat, which originally started here, is going to go directly also east to try to catch him. So the mouse is traveling at a speed of 7, and therefore this distance from here to here would be 7t. Correct? And then the distance that the cat would travel, obviously, is from here to here. But we also know that from here to here is 60. Right? They gave you that in the question. So the distance, which is equal to speed times time, those two distances must be equal in order for them to catch each other. But you got to be careful because of the 60. So that essentially means that the 7t has got to be equal to the 13t, but we have to subtract from it 60 because it sort of came 60 meters behind. So that's why this calculation is like this. So solving for this, you get 60 is equal to 6t, and therefore t is equal to 10. So at 10 seconds, he'd be caught, and therefore the distance, this distance 7t, is 7 times 10, which is 70. So he's caught when this point is 70. So just put that in there. So he's here, he's caught, and that's 70. So he's still on the x-axis, so it would be 70, 0 as the coordinate. Now let's say the mouse decides to go west, meaning in the complete opposite direction. Then you have a scenario where he starts here, but then he's going to go this way. And the cat starts here, and the cat obviously is going to go that way. So again, we have to equate the distances. The distance of the cat and the distance of the mouse have to be the same. So the distance of the cat has got to be equal to the distance of the mouse. Now the distance of the mouse is 7t, but in the opposite direction. The distance of the cat, remember, from here to here is 60. So it's 60, but minus 13t. Because most likely you're not going to have a scenario like this. You're probably going to have a scenario like this, where if this is 60, the mouse is probably only going to have to go this much, and the cat will actually have to go this way. So that kind of a scenario. That's why it's 60 minus the 13t is this distance, which is 7t. So that's why you got that formula. It takes a little bit of thinking, but hopefully it's not too bad. So 60 is equal to 20t, and therefore t is 3. So that means that is 7t would therefore be 7 times 3, which is 21. So 21 seconds. Okay, so that means negative 21 actually, 21, 0. So there we go. So now that we have that established, let's draw a diagram. A diagram that kind of combines sort of this finding. So something like this, approximately. It's not going to be a work of art, but, you know. So this is the one extreme where it's minus 21, 0. And this was the other extreme where it was 70, 0, as we had previously calculated. And somewhere in the middle there is the center of the circle. We'll call it whatever you want. E is fine. I don't want to call it C for center because we all have a C. And then we have to understand that this mouse is going to end up at a point P, like had been previously discussed. So it's going to start off here, but it's going to end up somewhere like that. Correct? Okay. Now we have to start thinking about how to establish that no matter where he starts off at, he's going to end up on a circle, at the path. And that's what they were talking about, that all points of intersection lie on a circle. How do we establish that? Well, if his distance from the center of those 2 points is always the same, then that means he's traveling around on a circle. So that basically means that we have to show that his distance to the center of that point is always the same. So that green line represents the radius of this circle, and we have to show that basically. Okay, and then I think one more line will be sufficient to get this question rolling, and that is this line right here. I got to connect that, and then one final line I think will be required, and that's a perpendicular from there to there, and that should be enough. Okay, so let's go with this. Let's blow this up a little bit. Yeah, and then I'm going to actually move this up and give myself some space. Okay, that should be good. All right, so now first I need the coordinates of E. E is the midpoint of this and this, the way I've drawn it, because these are the endpoints, minus 21, 0 and 70, 0 and the endpoints. So the midpoint would be just 70 minus 21 over 2, and then 0 plus 0 over 2. And that is 49 over 2, 0. So this is 49 over 2 and 0, this point E. Okay, great. And then we have to get the radius, and the radius is going to be from here to here, which is 70, minus from here to here, which is 49 over 2. So the radius is 70 minus 49 over 2, and that is 91 over 2. So that's actually very important. We have to ensure that this is something that we get at the end. Okay, so now we've got to figure out probably a Pythagorean relationship. It shouldn't be that complicated. So here's my Pythagorean relationship. That's a right angle. This point right here is P. And I had previously, if you remember, pointed out that P, the coordinates, are 7t sine theta and 7t cos theta. That's the coordinates for P. Okay, so I think that should be enough to create a Pythagorean relationship on this. Which triangle should I use? Should I use the big one or the small one? I think I'm going to use the small one, this one right here. Okay, so here we go. PE squared, the hypotenuse, is equal to this side squared, which is the y coordinate, so that would be 7t cos theta, And then now you got to be careful, just this squared. So from here to here is 49 over 2. From here to here is this 7t minus theta. So from here to here would be 7t minus theta minus 49 over 2. 7t sine theta minus 49 over 2, like that. Okay, so now we got to expand this. So PE squared. All right, let's make sure we don't make any geometric, not algebraic mistakes. 49t squared. Let's see here. Cos squared theta. Okay, so that's pretty straightforward there. And then this one we have to expand. Okay, so we got 49t squared sine squared theta minus 7 times 49 t sine theta plus 49 squared over 4. Yeah, I think that's good. All right, let's keep trying to simplify this. 49t squared cos squared theta plus sine squared theta. I can factor that out. And then I think the rest, there's not much I can do at this point. Just leave it as it is. And then this, as you know, is equal to 1. That's one of the more famous trigonometry identities. So this is just 49t squared minus 7 times 49 t sine theta plus 49 squared over 4. Okay. And I think that's about as far as I can go there. All right, so let's move this up because we're going to need some space. Okay, so what do we do now? Where do we go from here? Okay, well, I'm going to draw that original diagram again, but just the very basics. Remember, you have the mouse here, you got the cat here, like that. And this was theta, remember? So, and this was P. So the distance from here to here was 7t, and the distance from there to there was 13t, if you recall. So on here, we're going to use the cosine law, and what the end result we will sub back into here, because I don't really see where I can go with this. But if I have something in terms of t, then I can get a numerical value, because I don't know what t is in terms of a numerical value. So here we go. I'm going to use the cosine law on this triangle. So that means CP squared is equal to CM squared plus MP squared minus 2CM times MP cos CMP, angle CMP. Okay, so CP squared, that's 13t all squared, right? And then CM, where if you recall, the cat starts 60 meters away, so that's 60 squared. MP is 7t squared. And then we got CM, which is 60, MP, which is 7t, and cos of that angle, cos of CMP. So this is 90, so CMP would be 90 plus theta. So the cos of 90 plus theta. Yeah. All right. Getting somewhere, hopefully. This is 169 t squared is 3,600 plus 49 t squared minus 120 times 7t. And the cos of 90 plus theta using trigonometry identities is the same as sine theta. Yeah. Okay. Put everything on one side. This is 120 t squared is equal to 3,600 minus 120 times 7t sine theta. I think we can divide through by 120. And when we do, we get t squared is equal to, let's see here, 30, right? 30 minus 7t sine theta. And therefore t squared, let's see here. The sine theta identity, it's actually cos of 90 plus theta is negative sine theta. So what did I do here? If I'm going to substitute this, then the sign changes. There we go. Okay. You got to make sure you don't make those subtle mistakes. Otherwise, it can mess up everything. Okay, so now that I've caught that, 7t sine theta is equal to 30. Okay. Very good. So now we can go back and utilize that. We have a numerical value that's very helpful. So now PE squared, let's see if I factor out, what can I factor out here? 49, I think. I'll get t squared minus 7t sine theta. Look at that. It all worked out. And then, of course, don't forget about that 49 squared over 4. Well, this t squared minus 7t sine theta is 30. So there you go. We got 30 in there. And that works out very nice. So I'm going to get a numerical value here. So factor out the 49. You get 30 plus 49 over 4. And if you add this fraction, it'll be 120 plus 49, 169 over 4. And remember, that's PE squared. So if you take the square root of both sides, this will be 7. That will be 13. It'll be over 2. And that is 91 over 2. Okay. So what I've shown is that no matter what the angle is, this PE is always, this PE right here, is always equal to 91 over 2. So put this in writing now. So we have proven that regardless of the value of theta, the radius of this circle will always be equal to 91 over 2. And therefore, that proves that all points P will lie on a circle. So that proves, therefore, that all points P will lie on a circle. So there we go. Very challenging, very challenging. All right, so now we get to the final part, C. C says, suppose that the mouse is intercepted after running a distance of d1 meters in a particular direction. If the mouse would have been intercepted after it had run a distance of d2 meters in the opposite direction, show that d1 plus d2 is greater than or equal to 14 times root 30. Okay, let's first draw a diagram. So essentially what this question is saying is as follows. The mouse will start somewhere, right? Let's say the mouse starts here, M for mouse, and it goes in one direction to P, where this is the first P, we'll call it P1. Then it traveled, obviously, a distance of D1. But if the mouse travels in the opposite direction and ends up here, which is P2, and we call that D2, that's where they're getting this inequality from. Okay, we have to show that. Okay, so the first is going to involve a theorem, and that theorem is as follows. If you have two chords, and we'll label these A, B, C, D, A, B, C, and D, that it's called the intersecting chord theorem. And it basically, very simply says that A times B is equal to C times D. So applied to this, we can do the same thing. This is D1, this is D2, and then what about here and here? Well, remember in the previous part, we had proven that this would be 7D0, and this would be minus 21, 0. the opposite ends of that circle. So this is 21 and this is 70. So using the intersecting chord theorem, d1 times d2 is equal to 21 times 70. Okay, so that's the first part of this question. Then the next part is something that is fairly famous, AMGM. If you haven't heard of it, no problem. It is arithmetic mean, geometric mean. This is a law, and that law basically states the following: that if you have two numbers, a and b, and you take their geometric mean, which is just adding them and dividing by 2, it's greater than or equal to, you take their arithmetic mean, it's greater than or equal to the geometric mean, which is you multiply them and take the square root. So in our case, we're going to apply this AMGM to d1 and d2. So it essentially would be that d1 plus d2 over 2 is greater than or equal to d1 times d2 under the square root sign. Okay, well, d1 times d2 we just got up here. It's 21 times 70. And so we substitute that in there. And then that is what 21 times 70 is 7 root 30 is d1 plus d2 over 2. And then if you just multiply both sides by 2, we get d1 plus d2 is equal to 14 root 30. And there you go. That's exactly what they wanted you to show.